This video provides an overview of the crop water use analysis, which is part of the Watershed Pro suite of decision support tools for irrigation. Crop water use is a strategic tool to assess how much water a crop typically requires over a growing season, and to look at the number of irrigations that are required to ensure that the crop does not go into water stress. Now, to demonstrate this, I'm going to create a new analysis in CropWaterUse. You'll need to go to the Tools menu at the top of the page and select the CropWaterUse menu button. You'll then see a menu with three options. The first option is to review all analyses, and you can view these analyses as a table of analyses or as mini reports. You also have an option to create a PDF report, which allows you to select individual analyses and then compile this into a report that you can send via email or you can print. But we're going to select option 2, create new analysis. So you'll notice that a new analysis has been created here. It's pre-populated with input data, it's ran the simulation, and it's created some output results. Now, it's able to do this by copying the last analysis that you ran. It copies the individual input values. If you're a new user and hadn't run an analysis before, it'll use a series of default values. Now, our analysis page is split up into 4 sections. At the top we have our input variables, then we have a summary output, and then we have some graphical outputs including an irrigation heat map, and then finally we have some summary tables describing statistics of the key outputs as well as annual summaries of the water balance components. So next, let's have a look at what our key inputs are. And we've split our inputs into 3 sections, one describing site information, one water balance inputs, and finally the cropping inputs. Now, our site information contains inputs relating to farm and field. Now, there is another tutorial on how to set these up. We'll have a quick look now. So with our farm, if you click the farm button, you'll see that we have a farm name and a climate station. So this climate station represents the data that we're going to use from the Bureau of Meteorology, which is rainfall and evaporation data for this analysis. We can change that by clicking on the dialog. It will use geolocation to try and find your nearest climate stations, and you can select any of these stations. If we click on our field button, we're presented with a range of properties, but you'll notice that some of these are greyed out and we can't actually select them. And that's because fields and paddocks are shared between CropWaterShed and CropWaterUse. Now, these are CropWaterShed items, they don't get used in CropWaterUse, so that's why they're disabled. Field size can be changed here, but it's also not used in this analysis. So for CropWaterUse, we can change the field name, and we can also change the rain gauge. So this is our local rainfall data, and the way that it works is once we've added a rain gauge to our field, we can enter in new values, and that overrides the data from the Bureau of Meteorology. So for example, if I put 12 millimeters in on the 3rd of December, so the Bureau recorded 19.8 millimeters, but in the analysis we're going to use 12 millimeters. Now, this works from the period where we first enter some data in and where we last enter some data in. So if I put a value in on the 6th, say we had 12 millimeters again there, it would actually override the data on the 4th and the 5th using 0 values. We haven't entered data in here, but it assumes that even though we haven't, it's between our first and last entered data, and it will enter 0 values in there for those days. Close all this. Next, we have a couple of inputs that we'll use to estimate the amount of variability that we are getting in our results. So you notice in all of the chart results here we have a whole range of lines, and they represent individual years of the output. So the way the simulation works is for each year of our climate record, we will run our model and generate a line that will appear on the chart. And the extent of our climate data can be represented through this data from input. So you'll notice if I select from 1970 to present, the amount of data that you'll see on the chart reduces. Also, we have a based on here. We could use all years of data, which in this case means from 1970 to present, to generate the plumes below, or we could cherry pick just certain years. So we could pick years that were deemed El Nino years, or we could pick years that were designated La Nina years, and see how that changes our result. Next, in our water balance inputs, we have a rain gauge input. Now this is a copy of the same rain gauge input that we saw in our field dialog. So if you click on this, you'll notice you might have to scroll down, but you'll notice the rainfall values that we entered in previously. So if I close this now, we then have inputs relating to our irrigation. Now this analysis simulates irrigation, unlike the CropWaterUse tool, which requires you to enter your own irrigations. And this deficit value here is a refill deficit, or an irrigation trigger. So once the deficit amount reaches 80 millimeters, this will trigger an irrigation back to full capacity. We also have an efficiency value here, which allows us to account for losses in the irrigation. And although we don't define the type of irrigation here, whether it's surface or drip, etc., you'll need to ensure that you put realistic values in for the efficiency. Lastly, we have our crop inputs, and we have a crop selection dialog which we can access by clicking on the crop button. Now at the moment I've only got 2 crops here, cotton and mung bean, but we could add in more crops. We have a library of about 11 crops at the moment. So these are templates. So when you click on any of these, it'll make a copy of those parameters in that template and assign it as a new crop in your project. Now you can see here that we had some numbers representing the number of analyses that this crop is connected to. So these are your crops. No one else will have access to how you set them up. I can change the crop just by clicking on the name, or I can go and edit the crop parameters. Now these are the same crops that are used in the CropWaterUse analysis tool. However, the parameters that you'll see in each analysis in CropWaterUse and CropWaterUse will differ. These values in terms of fraction of the season and KC values will be the same across both analyses. So I wouldn't recommend changing any of these variables unless you know what you're doing. There is a way to scale these and change these through the main interface, so we'll have a look at that now. So I'll hit cancel here. Now we have a default planting day here that can be changed. We also have what we've called scaling factors. So we have a days to maturity here, which will scale our KC profile. We also have a water use factor here, which it's a modifier, and it scales our water use up or down. So typical is no scaling, and it uses what's in the template, in the crop template. Otherwise we can reduce our water use or increase our water use. And you'll notice on the charts below as I do this that the scale changes on this left hand axis. So there's some important information in this summary answer. It's telling us on average how much water we use and the number of irrigations that will be required for the input parameters defined above. Now next we have a range of charts that define our crop water use, our rainfall and our deficit, our soil water deficit. Now as I mentioned earlier, there's a plume of results here, or a series of results representing single years. So you can see as I move my cursor over these lines, it highlights particular lines, and if I wait long enough you'll see the year that was simulated for. The heavy line in the middle of all these charts, that's the average value, and that's the one that we use to summarise our results. So this first chart is daily water use, and we can see that as the crop growing stage increases, we're using more and more water. Now the next chart is the cumulative crop water use, and one thing you should notice that as we get to a final value here, which represents our maturity of our crop, so it's saying here our average value is 532 millimeters. That's where we get our answer in our summary answer above 532 millimeters. The next we have cumulative rainfall, and finally we have the soil water deficit. Now one of the characteristics of this chart, if you put your cursor over any individual year or line, you'll notice that we have these peaks and troughs. So in this case here we have a spike coming down. Once we hit our deficit amount on a certain day, we'll get a big increase in our value, and that's where we either apply an irrigation or we receive rainfall on that day. Now, rainfall or irrigation might not bring our deficit back to zero because there is water use occurring on that day, evaporation and transpiration. Lastly, we have an irrigation heat map. Now, what this explains is the number of irrigations that are required for this crop, and on the x-axis here we have the day number, or days since planting. The bars indicate where irrigations did occur in the simulation. So for this particular chart, you might find it more useful to include more years in your analysis. So if I go back up to the top and I present from 1900 and using all years of data, you'll notice that we have quite a detailed heat map now. So what it's telling us is typically for our first irrigation we'd be irrigating around that 90-day mark, sometimes as early as about 75 days. So we're assuming that we're planting on a full profile of water, so it's taking around that 84 days before we need to do our first irrigation. And then for the second irrigation, it's quite a wide spread. As we go through and look at further irrigations, you can see for the sixth irrigation it didn't occur very often. And this is reflected back in our summary answer, which states that we will typically need 2.9 irrigations, and that can be anywhere from 0 to 6 irrigations. So it means that some years we didn't need to irrigate at all, and some years we needed to irrigate 6 times. We can see this further through our summary tables at the bottom of the page. Now these are defining the maximum, minimum and average of the key variables, as well as a standard deviation. So if you look down further here, you can see the number of irrigations. Well, the minimum required irrigation was 0. Our maximum was 613 millimeters, which did require 6 irrigations. So on average, we only required 296 mils, which is equivalent to 3 megalitres per hectare, and that was delivered in 3 irrigations. And our last table here, we have our outputs on an annual basis, so we could go down through and find out where those extreme events occurred. So in summary, the key things we get out of this are the amount of water that the crop uses on average in that growing period, and also the number of irrigations and the range of irrigations that have historically been required for a predefined refill deficit.